So now let us move on to the next question. Question number 9. Question number 9 is here on the board. At what rate percent, at what rate percent per annum compound interest will rupees 10,000 amount to rupees 13310 in 3 years. So the question is at what rate percent? So here the unknown quantity is the rate this time. Per annum compound interest will rupees 10,000 amount to rupees 13310 in 3 years. So the principal is given 10,000, amount is given as 13310, time is given in 3 years. So you need to find the value of the rate percent. So let us write the formula. A equals to P into 1 plus R by 100 to the power n. So amount given is 13310. Principal is 10,000. So is 1 plus rate is given as, that is what is to find, and n is 3 years. So we write it as, so there is a trick here to solve this question, and what you have to do is 1 plus R by 100 to the power 3. You can see whatever the factor inside the bracket, you cannot resolve it, you cannot solve or get a value because R is involved. So you see to this entire thing, what is the power 3? So you have to make the left hand side any number raised to the power 3. So you have to express this number to power of 3 of any particular number. So let us see what it comes to. So it is cube. So which number's cube is 1331? So 11 cube is 1331 and 10 cube is 1000. So it is 11 by 10 cube. So this is what you have to do. And right hand side is 1 plus R by 100 power 3. So 11, since this power 3, the base power is 3, so you have to express this also in terms of powers of 3, so that we can take the cube root on both sides now and we get the value as 11 by 10 equals to 1 plus R by 100. So it is 11 by 10 minus 1 equals to R by 100. So 1 by 10. So R is equals to 10%. So here it is again. Amount. The formula is here. Amount is given as 13310. Principal 10,000. So this value you need to find the value of R. Time is 3 years, so you have to express the number on the left hand side in the terms of the power of 3, because this side is power of 3. If it is having 2, you have to express this in power of 2. If it is in powers of 4, express this in powers of 4, so that you can take that root and we can finally get that. So here it is 3, so you make it cube both sides, then you take the cube root and you can the value of R. So this is your question number 9. Very important question. Now we move on to question number 10. Question number 10. Determine the rate of interest for a sum that becomes 216 by 125 times of itself in 3 years compounded annually. compounded annually. Now what is given here in this question is determine the rate of interest. Again, the quantity to be found is the rate for a sum that becomes 216 by 125 times of itself. So the sum becomes this much of itself, that means this is the amount. It has become this much in 3 years. So let the sum be P, let sum is equals to P. So we have amount equals to P into 1 plus R by 100 to the power n. So amount will be 216 by 125p, that is equals to P. Why? This is the sum and this sum has become, the amount is this much times of the principal, that is P. So this and 1 plus R by 100 to the power n is 3 years. So here you can cancel both sides. Now you can see power 3, so this also has to be power of 3. So it is 6 by 5 whole cube. And this is 1 plus R by 100 whole cube. So now you take the cube root on both sides. So 6 by 5 equals to 1 plus R by 100. So taking cube roots on both sides, it is this. Now 6 by 5 minus 1 equals to R by 100. So it is 1 by 5 equals to R by 100. So we have the rate equals to 20%. I hope it is clear now. Very simple. The same type is the previous question number 9. Like, so now we move on to our next question number 11. This is important to understand. That is, the sum becomes 216 by 125 times of itself. That means this is the amount that has been, the sum has become this much after 3 years. Okay. Our next question number 11 is, a sum amounts to, all these questions are very important. From the examination point of view, these are the very important questions. Do take care of this seriously. A sum amounts to rupees 9680 in 2 years and to rupees 10648 in 3 years, compounded annually. Compounded annually. Find the sum and the rate of interest per annum and the rate of interest per annum. So let us see to this question. A sum amounts to rupees 9680. The sum is unknown, that you have to find the sum. In 2 years it becomes 9680 and in 3 years it becomes 10648. Now find the sum and the rate of interest per annum. So the time given is, in 2 years it is amounts to 9680 and in 3 years it becomes 10648. So let the sum be P and rate be R percent. So let sum equals to P and the rate equals to R percent. In the first case, so in the first case it amounts to this. That means 9680 equals to P into 1 plus R by 100 to the power of 2. This is number 1. So okay, amount, principal, this. In 2 years it becomes this, so power 2. Second, this is the value 10648. This is the amount after 3 years. So we'll write 1 plus R by 100 to the power 3. Is okay. Both these equations involves two variables, P and R. So you have to first get rid of one variable, either P or R. So you can see, if you take the ratio of 2 by 1, 2 is to 1. So 2 by 1 you get P eliminated. So we have 10648 divided by 9680 equals to 1 plus R by 100. This by this, so this is PP cancel, this is power 3, this is power 2, so 2 times cancelled, this divided by this. So from here you calculate the value of R, so 10648 by 9680 minus 1 equals to R by 100. So if you solve this, I think I write the answer, so it's coming to 10%. R equals to 10%. Now if you put the value of R in any of these two equations, you get the value of P. So let us put the value of R as 10% in number 1. So rate coming to 10%, so for putting in 1, so 9680 equals to P into 1 plus 10 by 100 to the power 2. So this 9680 equals to P into 11 by 10 square. So 9680 equals to P into 121 by 100. So thereby we have P equals to 9680 into 100 divided by 121. So it is 8,000. So the sum or the principal coming to 8,000. So the next question is number, I think 12. 14. Question number 12. Let me write it. So question number 12 is, in what time so now this time you have to find the time is rupees, in what time rupees 800 amounts to rupees 882 at 5% per annum compounded annually. Compounded annually. The question is that what time rupees 800 amounts to this. So we have the formula. Amount is P into 1 plus R by 100 to the power n. So amount is given as 882, P is 800, it is 1 plus rate is 5%, 5 by 100 to the power n. Here also you have to do something, and that what we have to do, let us first write this step. So it is 20, so it is 21 by 20 to the power n. See, the right hand side is 21 by 20 power n, the base is this. So this side also you have to make the base same, equal to 21 by 20, so that you can equate the powers, right? So in exponents you have studied, if the base are the same, then powers will also be the same. So if the base you can make it same on both sides. So it is 8h2, if you reduce it by 2, you have got 441 by 400, and that is 21 by 20 power n. So what we can write? 21 by 20 power 2. So it is 21 by 20 power 2 equals to 21 by 20 power n. So both sides, the base is the same, 21 by 20, so you can equate the powers. So n equals to 2 years. Everywhere it is the same formula we are repeating, using repeatedly. So one factor or the other, one unknown quantity, you have the formula A, P, R and N, 4 variables are present, unknown quantities, out of which 3 are known and 1 is unknown. That is what we need to find according to the conditions or the situations given in the question paper or the question. Right, now we move on to the next question, number 13. 13 again I take in what time will rupees 64,000 amounts to rupees 68921 at 5% per annum interest being compounded half yearly. So this question says in what time, again we have to find the time, will rupees 64,000 amounts to this at 5% per annum interest being compounded half yearly. So the amount is given this much, principal is this much, but this time it is the interest is compounded half yearly. So you need to use the formula for the interest for half yearly. So it is P into 1 plus R by 200 to the power 2n. The amount given is 68921. P is 64,000. So it is 1 plus rate given is 5. So it is 5 by 200 to the power 2 n. So you have to find the value of n. So it is 68921 by 64000 equals to again 41 by 40 to the power 2n. So obviously we have to express it in the powers of 41 by 40, right? So it is 41 by 40 power 3. You can see it is cube. 40 cube is this one. Obviously 41 cube should be 68921. Obviously I also don't know. You have to calculate it. So this is 41 and 40 to the power 2n. So by equating, since the bases are same on both sides, we have to equate the powers. So 2n equals to 3 or n equals to 3 by 2 years. Or that equals to 1 by 2 years. So the time is 1.5 year. So in what time will rupees 64,000 amounts to this much at 5% interest being compounded half yearly. So same thing, everything remains the same, only thing in the formula we have changed the value because r is divided by 2 and time is multiplied by 2. So thereby this formula. So time coming to 1.5 years. So now we move on to question number 14. A sum of money doubles itself. A sum of money doubles itself at compound interest in 15 years. In how many years will it become 8 times? Will it become 8 times? So the question is, a sum of money doubles itself. If the sum is P, it becomes 2P. At component is in 15 years. So in how many years will it become 8 times? So now we have let the sum be P. So you have thus becomes doubles itself. So doubles means amount is 2P, is P into 1 plus r by 100 to the power of 15. So we have p and p cancel out. So 2 equals to 1 plus r by 100 to the power of 15. So let it be equation 1. So in how many years will it become? 8 times. So the amount now p becomes 8p. So 8p equals to p into 1 plus r by 100 to the power of n. So p and p cancel. You have got 8 equals to 1 plus r by 100 to the power n. So 8, we can write 8 as 2 power 3 because 2 is equals to this much. So you have to write here 2, if you write 2 power 3, this is 1 plus r by 100 to the power n. Now in place of 2 we'll write this one. So this is 1 plus r by 100 to the power 15 to the power 3. So it is 1 plus r by 100 to the power n. Now what we get? Left hand side it is 1 plus r by 100 to the power 45 equals to 1 plus r by 100 to the power n. So if you compare both sides, bases are the same and the powers then will also be the same. So here we have n equals to 45 years. So the sum will become 8 times of itself in 45 years. So all these questions that I have discussed here are very important from the examination point of view, but then you need to practice a lot. There are so many other types of questions are also there in your book, you will find. So you solve all the questions, but what I feel after going through this, I think you will be gaining in confidence, and so you will be able to solve the questions, and you can think, you can apply yourself in solving the questions. So better have a look. Now we will discuss about the applications of the formula of compound interest, where you can find its application. So there are many areas which we get the applications, just like in the growth of population, when the population increases, or the depreciation in the values of the machine, because machinery, for example, you want to purchase of your sale of your car, so the value in due course of time gradually depreciate, means decrease. So we'll try to find out how this happen, and we'll try to solve the problem. But before that, just have a look. So now we will discuss about the application of the compound interest formula, right? So application of compound interest formula. So you'll find its application in this type of situations: increase or decrease in population, growth of bacteria, if the rate of growth is known, obviously, if the rate of growth is known. Number 3, the value of an item if its price increases or decreases in the intermediate years. So see where you can find the application of the compound interest formula. There are many situations. A few are here: increase or decrease in population, growth of the bacteria. If the rate of growth is known, obviously the value of an item, if its price increases or decreases in the intermediate years. Value of an item is price. Value of an item, I suppose, means machinery parts, some scooter or bike or whatsoever. If up to coming years, the value keeps on depreciating, means goes on decreasing. So these are certain areas where you can find the application of the compound interest formula. Now we'll see the formulas, right? The first one is of growth, appreciation. Population after n years. Is equals to P0 into 1 plus R by 100 to the power n. Population after n years is P0 into 1 plus R by 100 to the power n, where P0 is the present population. Number 2, population n years ago. Population n years ago is equals to P0 divided by 1 plus R by 100 to the power n. Number 3, if the rates are different for different years, then the present value, the P is P0 after n years will be P0 into 1 plus R1 by 100 into 1 plus R2 by 100, 1 plus Rn by 100. But P0 is the population or price or measure of quantity, etc. present, right? So this is for the growth one. We will write the formula for depreciation. So population after n years is P0, the present or the current population, into this one. Population n years ago, suppose 5 years back, P0 by this. Rates are different for different years. We have P into P0, the same like the previously that we have done. Now this one. Next one is for depreciation or decrease. So in this case you write population after n years. Population after n years is equals to P0 into 1 minus R by 100 to the power of n. I think this is now applicable very much in the corona epidemic time. After a few months or so you can find the decrease in population, isn't it? And number 2, population n years ago. Equals to P0 divided by 1 minus R by 100 to the power of n. So these are the formulas. These are the formulas for the growth and the depreciation. Now let us solve 1 or 2 questions on this. Let us see to the first question. the present population of a village is 5420. If it has increased at the rate of 4% every year, what was its population? What was its population 2 years ago? So it is growth. Present population of a village is this much. If it has increased at the rate of 4% every year, then what was the population 2 years ago? So we have the formula. Population 2 years ago is equals to P0 1 plus R by 100 to the power n. So we can write this P0 is how much? 5420 divided by 1 plus rate given is 4%. So 4 by 100 2 years ago. So power 2. So if you solve this, you get 5011. So this is your population 2 years ago, P0 by this. So if you solve this, you're getting 5011. So question number 2. The value of a machine purchased two years ago depreciated at the annual rate of 10%. If its present value is rupees 97200, find number 1 its value after 3 years, its value after 3 years, and number 2 its value when it was purchased, its value when it was purchased. So the value of a machine purchased 2 years back, the machine was purchased 2 years back and depreciated at the annual rate of 10%, means the value of the machine decreases at the rate of 10%. Present value is given as 97200, so what would be the value of the machine after 3 years and what was its value when it was purchased 2 years back? So we have the first one, value after 3 years. Value after 3 years equals to P0 into 1 minus R by 100. Only difference is the plus and minus. If it is decreasing, it is minus. If it is increasing, it is plus. Rest same. Now What is P0? 97200 into 1 minus the rate is 10. So 10 by 100 to the power 3. So this is coming to 70858.80. So value after 3 years is this much. And then number 2, I am leaving out the calculation. Value when it was purchased. It was purchased when? 2 years back. Purchased is equals to P0 divided by 1 minus R by 100 to the power n. So this is equals to 97200 divided by 1 minus 10 by 100 to the power of 2. This is coming to 1, 2, 1, 2, 3. So this is the value when it was purchased. This much, 1,20,000. This is the value after 3 years. Because the value is depreciating. So after 3 years it is this much. 2 years back it was this much. And at present it is 97,200. And after 2 years back it was 1,20,000. So these are the formulas and the questions of this type will be there in the application of compound interest formula. So this concludes this chapter, and hope you have understood. If not, go through the video once again. All the parts of the videos I am doing it in parts because the video becomes too large. So go through all the parts. I don't think there is nothing that you won't be able to understand. So keep motivating yourself. All the best.